Good day everyone. We will discuss on replacing OR with union operator for select queries in this video. Let's get started. I'm going to use database JBS Wiki for this demo. I'm going to create two tables, table 1 and table 2. Both these tables will get its data from a backup table called table2 underscore backup. Table 1 and table 2 will have primary key constraint created on column 1. So let's enable statistics time comma IO on. Let's execute this select query, which basically retrieves a distinct value of table2 dot column 2, comma table2 dot column 3 from table 1, which is joined with table 2, and the join condition is table1 dot column 1 equal to table2 dot column 1, or table 1 dot column 14 equal to table 2 dot column 14. So we have an or in the join condition. So let's enable the execution plan and then let's execute this query. So this query is expected to complete in 9 seconds. We'll look at the execution plan once this query completes, and then we will take it forward. So if I look at this execution plan, what I'm able to see is like we have a cluster index scan on table 2 and then a cluster index scan on table 1. And what is odd here is like we are sending close to 80,000 rows to an table spool operator, and then this table spool operator sends close to 100 million rows to the nested loop operator. So what I understand is like there are scenarios where you will get into performance issues if you have table spool operator on the inner side of a nested loop. So if we look at this article which is published around Jan 15, 2019, we have this information wherein it basically explains that spools improve performance in majority of the cases, but it's based on estimates. Sometimes this can be incorrect due to unevenly distributed or skewed data, causing slow performance. You can actually disable the spool on the inner side of the nested loop with trace flag 8690. So keeping this in mind, what I'm going to do is like I'm going to enable 8690, thinking that it's going to help us for this particular query. So before that, let's look at the IO information. So what I'm seeing is like these are the IO information that was performed by this particular select query. Yep. So let's mark it down here, and then let's check that. So what I'm seeing is like table 1, we have a logical reads of 11,176, and then for a table 2, I'm able to see like a logical read of 436. And on the work table, which basically is used by the spool operator, we are able to see like 481,000 logical reads. So now that we know like the work table, which is basically because of your spool operator, it is taking this much of logical reads. What we'll do is like let's enable 8690 trace flag, hoping that that is going to help us. And what I'm seeing is like the previous query completed in 9 seconds. So let's execute this query with a trace flag of 8690 and then see if it is completing within 9 seconds. And let's look at the execution plan also. So what I'm seeing is like it completed in 10 seconds. Like it took more than it took close to 1 more second when compared to the last execution. With the trace flag 8690, it took 10 seconds. Without the trace flag, it took close to 9 seconds. So actually, the query is regressed with this particular trace flag 8690. So what I'm seeing here is like the cluster index scan that is happening is sending close to 100 million rows onto a nested loop, and we have an sort warning. And the query, I don't think it has actually performed well. So let's copy this IO stats for this particular query, and let's compare it with the previous one. Yep. So what I'm seeing here is like now with trace flag 8690, what I'm seeing is like there is a drastic increase in logical reads as far as table 2 is concerned. work table, and the work table is having zero logical reads. But if you look at the logical reads as far as table 2 is concerned, it is like um, it is close to like 14 lakhs 70,000 logical reads, and without trace flag 8690 it took close to 4 lakh 80,000. So basically like you can't compare between table 2 and work table, but if we compare it as a whole, what I'm seeing is like the logical reads have increased at least by 3x, so doesn't seem like a good one. So let's not go with the query trace on 8690, but what I'm going to do is like I'm going to rewrite this query, and instead of using an OR, what I'm going to do is like I'm going to separate the join condition and use an union operator. So we have the same query. Instead of the OR operator, what I'm going to do is like I'm going to write this query with first join condition, which is table 1 dot column 1 equal to table 2 dot column 1, and then I'm going to do an union with the second condition, which is table 1 dot column 14 equal to table 2 dot column 14. So let's enable the execution plan. We have the execution plan enabled. Let's execute this query. This query is no longer taking 9 or 10 seconds. It is completing in milliseconds. So if you look at it, it is basically completing in 179 milliseconds. It's like an maybe like 50 times 50x improvement, to be frank. And now if I look at the execution plan seems to be little messy when compared to the previous one. Previous one it was very simple, but this one is like little wider, because we have a union and then we are repeating the query twice with different join condition. And what I'm seeing is like we are not utilizing nested loops anymore. We are using hash match and merge join. And then we are no longer sending 100 million rows. We are just sending 10,000 rows. Again, 10,000 rows for table 2, which is same as what we have on the table. So we are estimating 10,000 rows, and then we are reading 10,000 rows and returning 10,000 rows. And this way, the query is like improved by 50x times. And a simple rewrite by changing an query that has an OR operator in the join condition to a union uh, uh, resolves our performance issue, and also like there is an improvement of 50x. That's it for this video. Thanks for watching. Have a great day. Jai Hind.